Okay. Hello, everyone. Thank you for your time. Today, our capstone team will be giving our final project presentation on workforce productivity measures. I myself am Michael Borman, and alongside me are
My name is Alexander Ford. I'm an industrial engineering student.
Daniel McDermott, also industrial engineering.
I'm Sharon Lee, major in computer science.
Juan Carlos Arguello, majoring in industrial engineering. Introduction to the Penn State Center for Health Organization Transformation. Penn State CHOT serves as a research center for industry and university healthcare professionals to come together to research, implement, and support healthcare organization transformation initiatives. According to PSU CHOT's homepage, the center relies on multidisciplinary approaches to advance and link system designs and organizational technologies in innovation research. This approach is very contemporary in contrast to similar research centers and allows for PSU CHOT to be particularly creative and innovative in its research, investigation, and implementations. Some of the roles includes different types of engineers, industrial engineering, engineering science and mechanics, mechanical engineers, as well as doctors, computer science, and supply chain professionals. Introduction to the problem at hand. The Penn State Center for Health Organization and Transformation is looking to develop standards and productivity measures in process for advanced practice providers, or APPs. APPs include nurse practitioners, physician assistants, and other healthcare professionals that perform various roles across healthcare. The roles of an APP are to plan and accomplish treatment goals, shorten length of stay of patients, maintain communication with medical care team, and improve patient outcomes. To help understand the daily process, the group researched and developed a process map on inpatient APP roles, which can be seen here on the right. The project problem statement is that currently productivity of an inpatient's APP is measured by work-related value units, or RVUs, which is generated from billing data. The issue with benchmarking productivity of RVUs is that the APPs on the inpatient side don't bill. Therefore, there's currently no way of benchmarking inpatient APPs productivity.
So for our project, we kind of went forward and we set three objectives. So first would be to measure the productivity specifically for the Hershey Medical Center. And to do this, we're going to be using Cerner, which is a data management company that Penn State works with. The second is to be set baseline for productivity. So this ensures that all the inpatient APPs are working efficiently without over or under exerting themselves. And then the last objective would be to create a software that can model this productivity index. And ideally, this would be tied into that Cerner database we have that would allow this to be repeated in the future. So our team has identified some key benefits from undertaking this task. And the first is to get a basic understanding of the performance of any given APP. And kind of what this allows us to do is then focus and identify areas or even departments or specialties that may need more improvement, or on the other side could be overexerting themselves. And then, as well as kind of mentioned earlier, that there's not a lot of billing data tied into the efficiency measure. So we're going to get increased accuracy of the billing data we can do for the inpatient APP side. And then as well as overall gather efficiency factors and determine how we can help the inpatient APP team work more efficiently. So our project approach, first is going to be starting to gather the data we have, and that's mostly going to be with Cerner, an organization that Penn State Hershey Hospital utilizes. And with that, we're going to have to start analyzing it. There's multiple information we're given. We're given everything from time spent per patient to time spent in various tasks and various roles throughout the day. So then we're going to use that data to perform a data analysis to establish the key performance indicators. And then we're going to develop a software model to perform the DEA, and we'll explain in the next little bit of what the DEA actually is. And then the final step would be to develop the productivity visualizations to kind of visually see how different specialties or departments may be varying against each other.
So the group decided the most effective way to analyze the APP data received from Cerner was to perform data envelopment analysis, aka DEA. So what DEA does is it constructs a composite KPI or key performance indicator, which is the ratio of a weighted sum of outputs to a weighted sum of inputs. The reason why DEA is so effective for this project is because it enables us to make comparisons between multiple inputs and outputs to yield a single measurement of overall performance. DEA also yields targets for performance and any gains realizable through changes in scale or size. So to explain more about what DEA is, we set up a small three-dimensional example here. So here we have an example of 11 power plants, each with a single input, which would be power generated, and 2 outputs, which is capacity and labor, seen below. To perform DEA, you need to first establish your most efficient, in this problem, plants. So what we did was we took the ratio of the 2 outputs to the single input. So here would be output 1 capacity divided by input 1 power. And then the third column, it would be output 2 divided by input 1 labor over power. As you can see, the highest ratio for the second column, which is capacity and power over power generated, which would be plant number 6. And then for the third column, the highest ratio seen would be power plant 5. So in this next slide, you can see that power plant 5 and 6 are going to be the furthest away from the origin on the graph. If you draw a line between the two, you can see this black line here is now become our efficiency frontier. To dive deeper into how to calculate the relative efficiencies of the other plants, you can see here plant number 10. To find the relative efficiency, you can take the distance from the origin to plant 10 along that red line over the overall length of the red line to the efficiency frontier. When you do that for each of the power plants, you can graph their relative efficiencies seen here as ratios of those red lines. As you get into other processes with more than 2 inputs and outputs, it becomes a very abstract problem. Overall, it keeps itself as an optimization problem, but the calculation for theta becomes a lot more complicated.
So here are some advantages of using the DEAs. So it shows areas of investigation. It shows the difference between efficient APPs and the inefficient ones. It provides objective measures of productivity, assuming the data is accurate. It works with multiple variables. And there are also some disadvantages and limitations of DEAs. It can take a while to do by hand, and it only gives relative efficiency, so there's no absolute measure. And it should only be used to compare like decision-making units. How it applies to APPs. The current metrics can act as inputs and outputs. So things like average patients per day, time per patient, chart review time per patient, etc. APP uses decision-making units and identifies the best performers.
Okay, so the results of our project were fairly straightforward. The first thing we did was we threw all the APPs into one pool and performed DEA on that. And we identified 12 APPs based unfiltered on specialty, patient scene, or anything else that were along the efficient frontier, which we call our efficient APPs. You can see them in this table. They have an efficiency score of 1. And so the next thing we did was visualize our results in a histogram. And what you can see here is that almost all APPs were very inefficient. This isn't really surprising when you consider that depending on the specialty, an APP might be doing something completely different. For example, a neurosurgeon, you can't really compare to a dermatologist. They do completely different things. But you can see the distribution of efficiency scores for that and the KPI distributions. We wound up running this analysis for 39 specialties. So we're not going to go through all of them in this presentation. We have the images and tables in our report, which is accompanying this. So the next thing we did was we filtered our results by the number of patients seen as recorded by Cerner. So the way we did this was we checked the Cerner report's patient seen count, which measures the patients an APP sees in a month, took the average over the observation window, which in this case was 1 year. And then anyone who was 3 standard deviations away from the mean average result, we just figured they were an outlier. We're not counting them. We're all familiar with the Spider's George example of statistical outliers. These patients either saw way too many or way too few patients per month, or anyone who only saw 1 patient per month got removed. And you can see that now we only have 6 efficient APPs when not filtering by specialty. And so what you can see is this didn't really change the distribution of efficiency scores. That's still most people being highly inefficient. And the KPI spider chart isn't very useful when you're looking at hundreds of APPs from various specialties all lumped together. But when we look at them from a single specialty, next slide, you can see that actually filtering out the outliers did have an impact. What you can see when we don't control for patients seen is a lot of people are inefficient in anesthesiology, but once you remove anyone who's only seen 1 patient per month average, or who's seen some ridiculous average number, you wind up with the lower value being in the 30s to 40s range, and it winds up significantly different from the overall thing. So you can also see when we look at specialties that the spider chart is a bit different. You can see it's actually usable. This is endocrinology, where we only have 3 APPs measured for this. And so you can actually track what each APP's thing is, assuming you know the color. And this one we had some trouble getting a legend on it. But so obviously this isn't the end of our project. Going forward, other teams could expand the KPIs included to include things like physical materials used, bandages, medicine used in treatment, etc. And that will tell you who's being most efficient in regards to physical objects used and things that cost money to replace. We also want to translate the code we used for DEA into dedicated software. Currently it runs on MATLAB and takes a bit of setup. It would be much simpler if we could just translate it into Python, and all you have to do to run it is run a .exe. So that is our presentation. Thank you for watching.